Hi everyone, my name is CHEE. In this video, I would like to present to you my FYP project, which is Automated Production Scheduling for High Mix Low Volume Manufacturing version 2. I will start my presentation with a brief introduction of my project. First of all, this is a continuous industrial project made for high mix low volume electronic manufacturer company. So, what is high mix low volume? High mix low volume is a concept that requires a high degree of customization in the manufacturing process to produce many types of products in low quantity. In order to help the company to improve its production efficiency and productivity, an automated production scheduling system will be developed so that it can automatically generate the production schedules. The system will have three major features, which are the automated scheduler using genetic algorithm to generate production schedule automatically, the system visualization tool to view the schedule, and the rescheduler that let the user reschedule the schedule. However, there are some problems in the existing system. First of all, the company would like to consider more constraints in order to produce a more accurate schedule. First constraint is that some orders require additional tooling or jig during the production, but only one order is allowed to undergo tooling or jig process at each time due to the resource limitation. Therefore, the order that require the same additional tooling jig should avoid overlapping with each other. Second constraint is the PCB defects. Some production lines are unable to detect the defect PCB quickly, so placing the defect PCB in the wrong production line would decrease the efficiency. Third constraint is the different starting time of production line, because in real life situations, not every production line will have the same complete time in the previous schedule. Next, the previous system visualization tools are unable to highlight the constraint clearly. Lastly, the rescheduler is only able to reschedule the schedules based on cut-off date and time and active line production flags. The company planners hope that there can be more ways to control how the schedule can be rescheduled. The problem statement will lead to my system objective. The main objective of this project are to include different set of constraints required for the genetic algorithm to generate production schedule. The three constraints will be considered are additional tooling jigs, PCB defects, and different starting time of production line. Next, to create a visualization tool that is able to align with the constraints so that the user can view the constraint violation easily. Last one, implement interactive rescheduling in the rescheduler and allow the rescheduler to reschedule existing planner's schedule. This is the module diagram of my project. The new features are highlighted in blue color, which included 3 new production constraints, a Gantt chart or dashboard that align with all the constraints, interactive rescheduling, and reschedule existing schedule. Last but not least, for the uniqueness of this system, this project is made as a customized solution to support the company manufacturing process. The proposed solution allows the system to fulfill the specific constraint of the scheduling problem faced by the company. The rescheduler also allows users to reschedule existing planner schedule to assist the planners to make a better decision. Therefore, instead of replacing human decision making, this system will serve to complement human decision making. In short, the proposed system will act as a decision-making support system. Let us proceed to the system demonstration now. This is the main tab of my application. The whole system is developed by using C# programming language and using Microsoft SQL Server as the system database. In order to generate the production schedule, we need to input the data required such as order, model, and production line data. To do that, we need to click on Input tab. After the Order tab, we can manually key in each order by using Add button, or insert the whole order Excel file by using Import CSV button. Let's click on Import CSV button. Next, browse the order Excel file and select it. After that, the order will be inserted into the system database. The model and production line data can be inserted into the system by using the same step. After we finish inserting all the required data, we can click on Setting tab. Here is the place that the planners can play around with the algorithm parameter setting. The settings consist of population size, generation number, crossover probability, and mutation probability. After we are satisfied with the settings, we can click on Run tab. Firstly, we need to set the starting time of the production line. It can be either same or different. In this case, I will choose different starting time for this demo. Next, we will need to define the starting time of each production line. I will set the starting time for the first production line to 2 o'clock and second production line to 4 o'clock. The other starting time I will remain it at 12 o'clock. The label below shows the starting time of each production line. After that, the production line flags indicate which production line that will be operated in this schedule. The constraint flag allows planner to choose which production constraint they would like to consider in this schedule. For this demo, I will use all the 6 production lines and consider all the 5 production constraints. After we are done with all the settings, we can click on Generate button and wait for the genetic algorithm to run. It will take a few seconds. After the algorithm completed, we will obtain the schedule after that. This is the dashboard of my application. At the top left part is the schedule details that show the details for each order in each production line. The green color indicates the order that completed in time, and red color indicates the order that is late. The bottom part is the Gantt chart. It will show the timeline for the schedule. In the Gantt chart, each order is given a label and a color that correspond to its production line. The red color indicates that the order is late, and grey color indicates the machine changeover happens between 2 orders. In the middle part is the summary of the schedule, which consists of number of productions that completed in time, number of changeover, and number of production that is late. Right side consists of the chart for production punctuality and production utilization. We can give this schedule a name and save it by clicking Confirm button. This schedule will be uploaded into the system database. We can find the schedule that we have saved just now at main page. The details of each saved schedule will be shown in the below section, such as the algorithm settings and the summary of the schedule. We can view the Gantt chart of the selected schedule at right side, or click the View button to go back to the dashboard and view the summary of a particular schedule. Other than generating schedule, the system also allows planners to insert the existing planner schedule that planned by the planner manually. Click on the Insert button and browse the existing planner schedule Excel file and select it. After that, the Excel file will be inserted into the system and we can see the existing planner schedule now. We can click on the View Detail button and view the summary on the dashboard. If there are some problems in the existing schedule, which include the system generated schedule and existing planner schedule, rescheduling can be performed on them. There are 2 types of mechanism for interactive rescheduling, which are date level rescheduling and order level rescheduling. Let us look at the date level rescheduling first. First of all, we need to choose a schedule that we would like to perform rescheduling on it. Let's say we want to reschedule this schedule 1. After selected the schedule 1, we can click on the date reschedule button and it will navigate us to this reschedule form. Firstly, we need to choose the cutoff date for the schedule. I will choose 7 o'clock, which means that the order that completed before 7 o'clock will remain unchanged. The orders that haven't completed before 7 o'clock will undergo rescheduling. The setting below is similar like just now. I will remain it the same for now. Click on the Start button. We will obtain the new schedule after that. Let us save the new schedule and do the comparison. As you can see, the 2 orders that completed before 7 o'clock are remaining unchanged, while the rest of the orders are undergoing reschedule. Besides that, we can also add in additional urgent order into the schedule and perform rescheduling on it. We can click on the Insert button, browse the new order Excel file and select it. The 3 new orders will be added into the system. We can click on the Start button again, and now we can see that the new orders are added into the schedule and rescheduled with the previous orders. The number of production changed from 10 to 13. The last feature is order level rescheduling. It will allow planners to fix certain orders using the order flag options. As usual, I will select schedule 1 to perform rescheduling on it. After selecting the schedule, click on the Order Reschedule button. These are all the orders that can be found in this schedule 1. We can select the orders that we want to flag so that the flagged orders will remain unchanged. Only unflagged orders will undergo rescheduling. I will flag the 2005 and 3002 orders. The remaining settings I will leave it at the same and click on the Start button. We will obtain the new schedule after that. Let us save the new schedule and do the comparison. As you can see, the two orders 2005 and 3002 are remain at the same position in the new schedule. Other orders will undergo rescheduling. If there is no need for any more rescheduling, the planner can deploy the schedule to the production team, and the production team will receive the schedule and perform the production. In conclusion, this system can definitely help the company to increase the production efficiency. I hope you enjoyed this video. Thank you for your attention.